In this video, I want to talk about some definitions and things we need to talk about when we're thinking of beginning to collect data. Okay. First of all, a little review of our sampling methods that we talked about. I have two soft drinks, one with caffeine and one without, and I wish to give them randomly to 26 students to test the effects. How would I do that with a calculator? So I'm saying how would I divide them into, a caffeine group and a non-caffeine group? So with a calculator, assign each student a number. Use randint on the calculator to select 13 unique or different numbers. The numbers will identify the students that get the caffeine drink. So this is an effective way to do it. Remember, we have to say unique, different numbers, because otherwise what if we had a repeat? Okay. Next, how would I do it with a random digit table? Assign each student a number. Use a line from the table and read left to right. The first 13 unique different numbers from 0, 1 to 26 will identify the students that get the caffeine drink. So again, we need to say unique and different numbers. We need to say the numbers we used, and then of course the rest we won't use. And finally, names on slips of paper. Using 26 identical slips of paper, write C on 13 pieces of paper and N on 13 pieces of paper. Have each student pick a slip of paper without replacing the paper after it's drawn to tell them which group they belong in. So again, 3 ways to do some random sampling. Now, why is random sampling so important? The biggest reason is that we hope to control variables that are out of our control by splitting people into groups. For example, if we're testing like dexterity or testing response time with that opener problem, there are some people that are resistant to caffeine and some people that react very strongly to caffeine. You hope through random sampling that those people with like characteristics are split equally into those groups. That's really the reason we want to use random sampling. Okay, our goal. So some definitions, and maybe you would want to pause and write these down. I'm just going to quickly talk about some of them. A bias. A bias is a really overarching idea. Anything that causes some outcomes to be systematically favored over others. So there are all different types of bias we're going to talk about, all different kinds of bias in our society based on race, ethnicity, gender, all these different types of bias. This is one overarching thing. If it causes something to be favored over another, then that is a bias. For us, it's often, how we gather a response or who we put in the group. Random sampling. So random sampling gives every individual a chance to be picked for the sample. Notice it's not an equal chance. So random sampling is anything where we incorporate randomness, but not everyone might have an equal chance of being part of our group. A simple random sample, every individual and every group has an equal chance of being picked. So this is kind of like, our slips of paper or something. Every person has a chance. I'm going to come back to this every group in just a minute. Okay. Stratified random sample. Large groups are broken into strata, a group with a like characteristic. So a strata is just a group. And then a simple random sample, an SRS, simple random sample, is done inside each strata. So let's just talk about these two. And sometimes how the stratified one is probably better for some situations. Let's say I wanted to conduct a poll on students at the high school, grades 9 through 12. And let's say it was concerning requirements for courses. In a simple random sample, my methodology might be I take every student's student ID and I randomly generate, let's say, 100 numbers, and I ask those 100 students that come up. Well, in that case, every single student had an equal chance of being picked, right? They had 100 out of X amount of students. And every group had a chance to be picked, meaning, as unlikely as it is, it's possible in that scenario to get 100 seniors in my sample. It's unlikely, right, out of the school 9-12 to get 100 seniors, but it's possible. So every individual and group has an equal chance to be picked. Now, a stratified random sample. This would say, let's start by breaking into classes. freshman, sophomore, junior, senior class, 9th, 10th, 11th, 12th graders. And then let's give every 9th grader, 10th grader, 11th, and 12th a number. And let's pick 25 from each grade. That way, we know we've covered every grade. Every grade has 25 students representing them. So this is a really nice method when you're worried about, is there some characteristic that might cause my results to be different? Okay. A cluster sample. A cluster sample is where randomness is used to pick a group. So let's say I wrote down on a slip of paper with my same example I just used, freshman, another slip sophomore, another slip junior, another slip senior, and I mixed those 4 pieces up, and I picked one, and it was the senior class. And then I just asked the seniors. So randomness was involved, and I used that randomness to pick a group that I would sample. This is used oftentimes in like quality control. Light bulbs or something coming out, maybe pick a box to check. They aren't checking every single bulb, and they aren't checking every box of bulbs. Maybe they have some system where they say every 100th one or something will pick a one box to check. Under coverage bias. Under coverage bias is where some groups aren't included or they're represented in the sample. This is something we're always worried about when it comes to polling for elections. Are we getting people with the right type of phone? Are we getting people with cell phones and landlines? Years ago now, in Minnesota, we had a poll that was way off. It was based on a governor's race. And typically in political polls, likely voters are sampled. And likely voters means that you have voted before. So if you're an 18 or 19 or even 20-year-old, you're not considered a likely voter because you haven't voted before. So polling was done for this governor's race, and it showed one candidate had really a very small chance of winning, and in the end, that candidate did win. That was Jesse Ventura. Jesse Ventura won because 18, 19, and 20-year-olds, college-age students, came out in droves to support him, and they had never been part of the sampling done to see what their opinion was. So they were a victim of undercoverage bias. Okay. Non-response bias. Non-response is simply where people choose not to be part of the sample. They're unable, they're unwilling to. This really, we have a problem with things like voluntary response. When you get something in the mail that asks for your feedback and you throw it away, you're part of the non-response bias, because the only people that actually do fill those things out and send them back are the people that feel passionately about it. And so therefore, the strongest responses are often the ones that are heard. Response bias. Response bias is anything that may cause an individual to give an untrue answer or response. My favorite example of this is that when I was in college, I took a Phi-Ed course. It was a required course, and the guy teaching the course was not a real great professor, and he was kind of unprepared. He usually didn't have the things ready for us. He didn't know what we were supposed to do. The day of the final, he'd forgotten to copy the final, so instead he gave it to all of us. It was an oral exam, and if anyone got one wrong, the whole class got it wrong. And none of us were real happy with him. We felt like he really had, kind of slacked off on the job. He handed us a mandatory, for every professor, they had to hand out a sheet that you graded them, and you gave your feedback on the course. And in most college classes, the professor hands that out and then leaves the room. He handed it out and then walked around the room to see what we'd given him, and when we were done, we had to hand it directly to him. So despite the fact that none of us were real thrilled with this professor, that is not what our evaluations of the course said. So a response bias is where there's something that causes you to give an untrue or an untrue response. Another kind of bias is the wording of the question. I would just urge you to read this comic, Pearls Before Swine by Stephen Pastis. So, one more lesson on bias, specifically under coverage. Back in 1936, at the Literary Digest was a magazine, and they conducted a poll amongst their readership about the presidential election. And overwhelmingly, Franklin Delano Roosevelt's opponent was favored to win. Overwhelmingly. So it came as a huge shock to this magazine and their readers when FDR won the presidential election. The reason the sampling was so off is because in the midst of the Great Depression, only the very wealthy could afford magazines. And the very wealthy were not Franklin Delano Roosevelt's main supporters. So you had this huge undercoverage bias. The very poor people, the poverty-stricken people, which during the Great Depression was a huge portion of this country, they were not polled at all because they couldn't afford the magazine to be part of the polling. I will leave you with this